All right, so let's discuss the proof of the convergence theorem for the Winnow algorithm. Okay, so remember, I've got to try to show that WT gets closer to W star at every iteration. Okay, so I'm going to call this thing phi t. All right, and then I'm just going to use the definition of the KL divergence to just write that thing down. All right, so then what I want to show is that that we make progress at every iteration. Okay, I want to show that that phi t minus phi t plus 1 is at least something or other. Okay, so that'll show me that I make progress at every iteration. Okay, so let me just use the definition of KL divergence here to just write these two quantities down. Put some parentheses there. All right. So nothing here for the definition. Okay, so this is log of a fraction, which is the same as the difference of logs. And so I have some terms here that actually sort of cancel each other out. And in particular, this term is going to kind of cancel out with that term, okay? So what I'm left with when I do that simplification is the log of the ratio of Wj at t plus 1 to that of Wj at time t. Okay, now the way the Winnow algorithm works, remember, is that to get from time t to time t plus 1, there's a multiplier. Okay, so this is just the definition of the Winnow algorithm, and I'm just going to write down the multiplier, right? Because this ratio is exactly that multiplier. And the multiplier is e to the eta yi xij divided by, and then the normalization factor right there. Okay, cool. So let me just write it out here. All right, I'm just going to write that out just to make things a little bit easier. So e to the eta yi xij. And then over here, I have sum over j, wj star, log of zt. All right, now guess what? The log and the e cancel each other out. And I get sum over j, wj star. And then over here, I get eta yi xij minus, and then this thing, actually, I'm just going to pull the log of zt out. And then I have here, but guess what? Remember at the very beginning when we defined wj star in the statement of the theorem, we defined it as a discrete probability distribution, so actually this thing is 1. Okay. So now I'm just going to write this sum over j over here as an inner product. So I'll pull out the eta and the yi, and then this is an inner product. Okay, so this sum over j turns into this dot right there. Okay. Minus log of zt. Cool. Okay, so now this thing right here, this thing right there, what do we know about that? Well, by the definition of W star, it's a classifier that has a margin of delta for all of the points. Okay, so for any I you have, this thing is greater than delta. Okay, and so this is by the definition of W star as being a delta margin classifier. Okay, now, so even though point I was misclassified at time t by Wt, it has nothing to do with this because this is all just about W star. All right, okay, so then this thing is just, I'll just write it again, minus log of zt. Okay, that is the first step. This is step 1, and I can't go any further without working with zt, so I'll do that in the next step.